My name is Robin Miller. I'm the Industry Partnership Communications Manager for Illinois Soybean Association, and I'll be your moderator for this session, which is called Equip Your Bin for Maximum Gains. Today, Ryan Thompson, Strategic Accounts Manager at AGI, will cover today's in-bin sensor tech and how it can transform a standard storage bin into an intelligent tool that benefits your operation. We'll have time for questions at the end, so feel free to take note of those questions, and we'll go around and take care of those at the end. So please now welcome Ryan with the AGI.
Good morning, everyone. Can you hear me all right? Okay, all right. Well, thank you for joining us here today. Hopefully bring you something educational and get you to think a little bit differently, or maybe open your mind to a few other things. I want to thank Illinois Soybean Association for allowing us this opportunity. We've had a great relationship with Illinois Soy for the last, I think, 4 or 5 years now, kind of based on education around safety and grain conditioning. And, so anytime they ask us to speak, it's always welcome, and especially for me, coming from South Dakota, I'll admit, we've always been envious of you Illinois growers, right? You got good soil, you get more moisture than we do, good yields. And I read in one of the news publications this year that you guys actually were the only state that actually hit 97% of your soybean harvest at 13% moisture this year. No? That fake news? Is that what that is? Okay, well, good. We're all on the same page then. Yeah. So I think dry soybean harvest is always something we fight a little bit, and this year was exceptionally bad. So in addition to talking about safety, equipping your bins for maximum gains, that's something we're going to really touch on here today. So just go along with that. But again, as Robin said, I'm Ryan Thompson, Strategic Account Manager with AGI. Really what my role is, we work with a lot of commodity organizations like Illinois Soy on education, on, like I say, bin safety and grain conditioning, but we also work with a lot of other different partners in the ag space that have a vested interest in the harvest of the grain that you're producing. So whether that's food and beverage companies, popcorn companies, biofuel, seed companies, everyone that's needing that grain pretty much conditioned correctly or to a certain set point or level, we work with them to help them achieve their goals, and also work with their customer base or grower base to help them be able to get that done on farm until it gets back to their facilities. I'll touch a little bit about who AGI is. Some of you may not be familiar with who AGI is, but more than likely you're familiar with the brands that are underneath the AGI umbrella. Want to talk about the tools that you or we use to condition or store grain. And through that, we'll talk a little bit about the AGI Bin Manager hardware and SureTrack software, which is our automated bin management tool, bin monitoring tool to be able to allow you the visibility within the bins to do that. And we'll also talk about safety, the science behind the bin manager, and what value does that bring an Illinois soybean grower. So again, you may not be familiar with AGI or Ag Growth International, but it's been around for a long time. Since 1996 it got founded. And really what AGI has done over the last almost 30 years now is just acquired some of the most and best reputable brands in the ag space for grain conditioning, storage, transportation, handling, right? A lot of brands up here that you probably know that were owned by AGI, like backhoe conveyors, Westfield augers, high roller, Nico grain dryers, a lot of good brands up there. So that was all very strategic in what they're doing. Again, getting some very reputable brands and doing that. And where we come into play here for this conversation today is AGI's bin manager system is the market leader in the bin monitoring space in the U.S. today. We're working with over 3,000 growers, monitoring over 20,000 bins just in Illinois alone. We're looking at 220 plus growers and almost 750 bins. So we're very proud of that fact, and as we continue to be looked at as a leader in that space. But as we talk today, I want to kind of wrap your heads around the fact of thinking about that 20,000 bins that we're monitoring. We're very proud of that and thankful for that. But when you think about that, that's roughly 10% of the bins in the United States right now. I think the last USDA report I looked at had us at about 225,000 bins across the U.S. on farm storage. And you think about that, the question I'm going to ask you, or the ask I have of you today, is to kind of open your mind a little bit and think about two things: how we produce our grain and how we store our grain, okay? Now, when we think about how we're producing that grain, I think it's pretty cool. I grew up in a time of one of the most technological advancements in our industry. Like when I was a teenager, BT corn come out, then Roundup, then double stack, triple stack, and then that leads into all the precision agronomy tools that we use to grow a crop today. When you think about that, we made that transition from composite soil sampling to zones and grid sampling. That turns into variable rate fertility, variable rate seeding, right? Now we get into the crop. We're scouting our crops with satellite images, infrared technology, drones. Now we're starting to see see and spray technology be more widely adapted. You know, scales on the grain carts, yield monitors, auto steer, all that stuff. All that technology we use today to grow the crop. Now when we go to store the crop, what do most of us do? We put it in a galvanized tin can, turn on the fans, and hope for the best, right? I'm not saying that's right or wrong, but with all the technology and the data that we use to grow that crop, I think we have enough new marketing opportunities, or today when the commodity prices are taking a little bit of a setback, as I have, every penny counts, so every investment counts. And what I'm going to try to relay here today is how having visibility and the knowledge of what's going on in your grain bin can provide more ROI back to you. Is that fair to understand? So again, as I got to think about how to talk to you folks today, or what we're going to talk about, I got thinking, okay, how do we maximize your grain storage tools? And trying to relate it back to some other things we have on farm. I'll give a free lunch certificate to whoever can tell me what this is. There you go. All right, I'll get you. All right, a ratchet, right? Every one of us has this on the farm, pretty useful tool. But as it sits here right now, that's what, maybe a hammer, a pry bar, maybe you dig something with it, self-defense device, right? But add a SAE socket to it, that tool becomes more useful. Add a metric socket set to that ratchet, it becomes even more useful, right? So look at our grain bins. Useful tool for our operations. You add fans to it, that tool becomes more useful. We add vents to that bin, it becomes more useful. We add a leg, that becomes more useful. I'd argue we add a bin monitoring system to that bin, it becomes more useful. So that's the leap I'm trying to make here on technology as it applies to how we're growing the crop to how we're storing the crop. Everything we look at, we're trying to make things more useful. But as it comes to that very useful and expensive tool, the biggest ROI we can provide back to you and the biggest focus that AGI has for your operations outside of an economic return is the value of safety. So I'd like to take just a little bit of time anytime I do a speech to just mention this and think about it. At the end of the day, we're in the technology age. At any point in time, we have a world's worth of knowledge and information at our fingertips at all times. And yet today, we're going to hear about some grain bin tragedy this year. It's going to happen, right? It's the nature of the beast. It's an accident for a reason because we have a lapse in judgment. So if any of you have encountered or experienced a grain bin tragedy, I have my sincere sympathies on that. I just ask, as growers, if we need to take care of each other in this industry, let's not always do our best to not get caught up in the moment. Let's take a second to have some clear thought, because every one of these situations is preventable. We ourselves get in a hurry. We make the decision to enter a bin. And our goal with our bin manager system is prevent you from having to enter that bin until it's time to sweep the floor. Okay? We want to keep you out of that bin because we can have those void air space accidents in a bin. Never climb into a bin if you absolutely don't have to. But if you do have to climb in a bin, make sure you have a 5-point harness. Make sure you're tethered off correctly. Always know or let someone know that you're going to go in that bin. And in most cases, all cases actually, always have at least one spotter there, if at all possible. Someone on the ground and preferably another one up on the platform with you, so you never go into those alone. Sidewall bridging still happens with some folks. I mean, just working on that can collapse and you can be engulfed in no time. And definitely never be inside that bin when that unload auger is going, because you can see, I mean, within a couple seconds, that's all you have to react to that. Within 5 seconds, you're probably down your waist. In less than 12 seconds, you're completely engulfed, So for you, your family, your employees, do yourselves a favor and take an extra second. I know things get hectic when we're at harvest or unloading trucks, but take some time to think about that. But with that, let's get into what we're here to do today. I'm going to talk about, again, AGI Bin Manager hardware and the SureTrack software and how we utilize that at AGI to help bring economic return to your operations. To be respectful of time, I'm not going to do a lot of justice to the science behind the system. We're going to talk a lot about the equilibrium moisture content, and because I get tongue-tied, I'll just say EMC going forward, if that's fair for you guys. We literally will put on 2-day training sessions down at our facility in Lenexa, Kansas, to just hone in on that and bring a better understanding. So I'll try to give you the Cliff Notes version today. But as we think about it here today, we'll try to make it a little interactive. What is, when you think grain conditioning, what does that mean to you? What pops in your head when you're thinking of the grain in your bids and you want to condition it? What does that mean? What are you doing when you're conditioning grain?
To the right
Moisture? Temperature? Okay. All correct answers. Grain conditioning at its core is pretty simple, right? We're talking about removing moisture, adding moisture, cooling the grain, rewarming the grain. We're doing all this for the simple fact that we're trying to put that grain in a safe storage condition. But to do that, there's some things we need to know, and that's back to EMC. And one thing I'd like to understand is EMC is actually a characteristic of your grain. It not only changes from one commodity to the next, but there's a couple slides here I'll show you. It changes pretty widely just from one variety to the next or one hybrid to the next. So we'll dive into that a little bit more. But again, it's a characteristic of grain. That's no different than if a certain soybean variety is known for having high protein, high oil, a defensive variety, offensive variety. It's a characteristic of that grain. We'll touch a little bit about the aeration systems, monitoring the ventilation, everything that goes into conditioning that grain. But again, the EMC at its core, what you're really talking about is identifying what is that grain's natural moisture content limit, or where does it naturally like to equate to. Because if I was to sprinkle soybeans on every table here, over time, soybeans are pretty adaptable. They're going to adjust to whatever the temperature and the humidity levels are within this room, right? So whenever we are storing our grain, that's essentially what we're trying to do. We're trying to create that ideal atmosphere within that bin to be able to store it as long and safely as possible, right? So again, we can't really do that to the maximum efficiency if we don't understand what is the EMC of the grain that we're storing. Because as I'll show you here in a little bit, we can't just assume that 13% is the magic number for soybeans. It's what the elevator wants to take it at, or they won't dock us if we stay at that level or below. But that doesn't necessarily mean that that's our target limit based upon how long we're going to be storing that grain. Now, it's important again because it's identifying the optimum moisture limit to store it as long as possible, but we're going to key in on thinking about 65% relative humidity of the grain. And the reason that's important is at 65% relative humidity, that's when mold growth will stop or slow down, and that eliminates one thing off the checklist that we don't have to worry about when we're storing our grain. It gives us information about whether or not that grain at present condition, if that's going to absorb moisture or release moisture. And it's also going to let us know what air conditions outside the bin do we need to search for to create that ideal atmosphere inside the bin for that specific grain. So it's pretty simple thinking about it. If I have dry conditions outside or in this room, those soybeans are going to release moisture, right? If we have wet conditions, they're going to be grabbing it up. So what do we need to do? So again, if I want to remove moisture, the main reason I'm looking to do that is for what? Mold, heat damage, things like that, right? when we think about the corn that we're offsetting our bean acres with, if we're starting harvest at 20 to 25% moisture, we actually have about 95 to 100% relative humidity in that grain. So right from harvest, we need to take 30% relative humidity out of that to be able to put that in a safe storage situation. We need to cool that grain, because just like the great seed companies that we work with and plant their seed every year, we want to extend the shelf life of that grain, right? Seed companies, they get it conditioned, they package it, they put it in the warehouse in refrigerated buildings to extend the shelf life of it, maintain the germination. That's essentially what you're trying to do with your grain. You're bringing it down to maximize the shelf life, but also we're trying to take one more thing off the checklist of worries that we might have. That's insect pressure. If we can get the temperature of that grain down to 50 degrees, 40 degrees, we're creating a dormant stage or a near lethal environment for insects that we don't have to worry about later. Now, rewarming. This kind of varies depending on where we're at. You know, definitely you need to look at rewarming your bins properly here, but it becomes extra important as we go north. You know, my country, South Dakota, North Dakota, Minnesota. You get a limited window on your drying opportunity days up there, but also your bins can freeze. Well, if we have frozen grain or cold grain in that bin, and I don't know about you folks, but on my acres, we can see 32 degrees one day and 70 the next, right? So we got these cans full of grain south side of those bins that are getting just pummeled. If our grain's too wet, or if it's frozen, whatever the case may be, and it heats up too fast, now we're essentially creating what we call bin rain or condensation. That's going to lead us to problems of having crusting and mold issues at the top of the bin as that moisture releases, right? So if we look at a proper way to introduce warmer air back into the bin over a longer period of time, we warm that grain up more gradually, we see a greatly reduced opportunity for condensation or bin rain to happen, right? So probably the one that's most important to all of us here in this room today is a little thing called hydration. Why would we want to add moisture to our grain in the bin, right? So I learned we had some fake news. You guys all didn't have 13% beans this year. Was there some 10s? 10%? 8 maybe? Right? Okay. So again, elevator is going to allow us to bring 13% moisture. If we can do that, let's do it, right? Let's maximize it, because we had good yields, but I'm not getting paid for every bushel that I harvested because Mother Nature once again showed us she was in charge, dried those beans down for us to keep them in a safe storage condition. But we have the opportunity to use the technology to be able to put some moisture, put some weight back on those bins, and put more money in our pockets at the end of the day. So when you think about it, a 9 to 10% bean, conversely to a 20, 25% corn, now we're looking at 40 to 50% relative humidity. So we need to add some humidity back into that grain. But we gotta be mindful of how we do it, because if you look at that chart in that yellow section, if we raise that back up to 13%, we're actually looking at about 70% relative humidity, right? So depending on how long you're going to be storing that grain, that may or may not be an issue. If I harvested in October and I'm looking to deliver right away in January, we're probably going to be fine, right? We got cold conditions, grain's going to be stored just fine. But if I'm looking to deliver on a July, August contract, or maybe this is unpriced grain because I'm not happy with the prices, I might be carrying this all the way into right before next harvest. Now it becomes important. If I don't understand that, I'm going to open myself up to potential risks of that grain going out of condition, and then it essentially kind of biting me on the hiney because I didn't know enough. All the dollars I was hoping to make, I just threw away in dockage again, right? So we'll dive into that a little bit. So again, just kind of looking at how we store grain. This chart provided by Dr. John Lawrence at our office in Lenexa. He's a former professor at Kansas State University and a lot of the brains behind our bin manager system. This chart just shows you how quickly grain can go out of condition, whether it's depending on how warm it is or how wet it is, right? So if I can get corn down to 15% humidity or 15% moisture, 40 degrees, I can store that for a year better. But again, how many of us can actually keep our grain at 40 degrees out in the out in the bins, right? So just kind of gives you a little bit of insight. Same on beans. 13%, 40 degrees, I got a year, but as that temperature climbs and that moisture adjusts, we're limiting our shelf life. So it's very important for us to understand what's going on in that bin. And again, I talked about 13% may not be the target we want to go for, even though that's what the elevator wants it. Again, let's think about how long do we need to store that grain. And the reason I say that and the reason EMC is important is this slide here. Now, again, this is a random pull of grain samples we've run through our lab. It's not to promote, disparage, criticize any of these brands up here. It's just a random sample. But what I want you to pay attention to is as you look at that relative humidity column there at 65%, again, I said earlier, the EMC not only will change from one commodity to the next, it's going to change from one variety to the next. So you can see we have a pretty wide range here, 10.5 to 12.8. So what that means is, again, if I'm looking to store my grain for a few months, is it probably, not the most detrimental thing I know. It's good to know it, but it's not going to affect me too much. But if I'm going to be storing this grain in the summertime or even in the next harvest, I want to know this because I want to know what is that variety's EMC, what's the best moisture to store that at so I can avoid any potential mold or quality issues. Because what I would look at, that top number, for example, if that actually has a EMC at 10.5, well, okay, this was the perfect harvest for it, right? We had 10% beans. But it means I'm not going to try to rehydrate that bin until I get within a month or two of my delivery window because I don't want to create any potential conditioning issues that may arise from it. Because if I'm storing it at 13, that's not that grain's natural EMC space. I am increasing my chance of a conditioning issue. The thing I find most interesting on this slide too is, again, industry tells us 13%. There isn't one variety on here that says my EMC is 13. I got a couple that are close. So again, knowledge is power. Be mindful of what we're trying to do. Incorporate it into the plan. So where does this come back for us as growers? What we're looking at is how to properly look at your hydration opportunities. So essentially look at a reverse shrink on your bins. Shrink factor for soybeans is 1.33%. So if I'm looking to see what I can do, I want to take the number of bushels I have in a bin, my shrink factor, the points that I'm hoping to gain, times my market price, and kind of come up with a dollar total. So for simple math, if I have a 50,000 bushel bin on the farm, and they're full of 10% soybeans, and I want to try to add 3 points of moisture to get what the elevator wants at 13, for every 1 point of moisture I'm adding back to that 50,000 bushel bin, that equates to 655 bushels, extra bushels just through weight, right? I'm not changing the number of bins or beans in that bin, I'm just adjusting the weight. So in this scenario, if I'm able to add 3 points of moisture, I'm just 5 bushels shy of 2,000 bushels that I'm now taking in. I'm giving myself the ability to haul more grain to the elevators than what I put into it at the end of the day, right? So that's important because even at these depressed markets, I mean, this was my new crop bean price at my elevator for this coming fall. At $9.50 beans, that still means that's about $19,000 back to my pocket. That's real money. That's something I'm probably going to need this year with the way things are going. Now think about it. Last year, when we were closer to $12 beans, close to $24,000 back in our pocket. Glory days of $14 beans, almost 28. So point of looking at some of the different pricing scenarios is no matter what's going on, this is something that can give us a positive return back in our operation and be used on other things within the business that we run, right? And I don't know your guys' situations, you don't know mine, but I'm speaking from my own experience. That $19,000 at this $9.50 price, that's as much, if not more important to me today than when I had $14 beans. I can make more mistakes at $14 beans than I can at these $9.50s. So I can't make too many mistakes this year. So. But looking at it another way, think about it this way. We got two 50,000 bushel bins on the farm. One is going to be held as status quo. The other one has a bin manager in it that we added 3 points in. Now, we always say our grain bins are our piggy bank. That's our cash flow. That's our revenue. So you have one bin at $475,000 and another bin at almost $495,000. Again, how do we think about this? These are the investments that we look at to generate a return, right? Put it in perspective of your marketing. I don't know what anyone's marketing ability is, but we think about this. If I remember correctly, we're probably looking at what? Roughly a 30-cent carry from March board to July board for beans right now. If I take that $19,000 that I added back to my bin, that's essentially equating to 38 cents a bushel. So that's going to be better than any basis push you can get from the elevator. But the way I look at it is I'm creating my own carry now. If I can actually hydrate my beans that much, I'm creating my own carry. So now that 38 cents tacking on to a 30-cent carry, I'm almost adding 70 cents a bushel if I'm carrying these beans from today to July, right? This is how we take the steps to try to generate more income for our operations. And same thing on $12 beans. You know, hopefully we can get there again soon. In that same scenario, we're adding almost 48 cents. So now we've added almost 80 cents a carry back to our crop by being able to not only take advantage of the market, but also being able to condition it more appropriately to provide some return. Now, 50,000 bushel bin, you know, that might be kind of big. We get a lot of questions of, okay, will a system like this pay for itself on a small bin? In my opinion, yes. This is real data from a grower of ours in Iowa last year. Stored it from October to March, added 2 points of moisture. Even on that 21,000 bushel bin, he had it contracted $11.32, $6,300 back in his pocket. Again, same math, he just added himself 30 cents a bushel by being able to utilize moisture outside the bin, put it back in the bin to add weight to those beans in a safe manner. So here's a good example of how you can actually see this stuff work within your bin using that technology. This is this year's data from a grower over in Indiana. And I think if you actually have visibility in your bin, this is what a lot of you are seeing within your own bins, right? We start harvest, beans are right on target, 13.5% at the bottom of the bin. Then as the day goes on, the beans get drier, and now we're throwing some 10s, some 9s, some 8s on top, right? Well, you're seeing that. He set it to auto hydrate, and now we're pushing that moisture front up through the bin. So we're utilizing the moisture that's already there, but we're also reintroducing air from outside, utilizing the humidity and pushing that up. So the reason I kind of did the screenshot here is you can see on sensor levels, 3, 4, 5, those adjusted from the left side of being on the dry side, you can see that moisture being added in on the right side, right? That's how we're able to add that moisture up. Now you are seeing at the bottom of the bin get a little bit drier than original, but that's actually by design because we're pushing the moisture up. The bottom of the bin, as we all know, is the first line of defense. They're the first to receive all the moisture. So as we see that moisture push up to the bin, we see our top sensors hit their target. System kind of recalculates, readjusts, and now the fans are going to only be running at a time to where it's adding moisture to the bottom of the bin. When this is all said and done, if I was to pull this bin up today, more than likely that whole bin is going to be showing green right now because we were able to condition that. Okay? Any questions so far on anything? So at the end of the day, this is really what we look to. This was a welcome surprise. A coworker and myself were working a show last summer, and he got this from one of his dealers. And again, this is what we hope to do. We want to focus on safety for your operations, and we want to look at how do we bring value back to it. And being able to do things like this with soybean hydration, we can do it with small grain hydration. These are the things that actually matter to us at the end of the day. We're talking soybean hydration here, soybean convention, but think about it this way too. On your corn, if we're running those fans nonstop, what do we typically see? We see the bottom portion of the bin get a little bit over-dried, right? Flip that around, shrink factor every point of moisture you lose below 15%, you're costing yourself 12, 15 cents a bushel almost. So a system like this also does the same thing in reverse on corn, where you're reducing the amount of over-dried grain that you get from running your fans. And that begs the question, when is the right time to run your fans? I'm curious, with what we have for audience here today, how many folks just turn the fans on and let them run 24/7 for a set period of time? No one? Awesome. You guys look at the humidity outside, temperatures, and you go on and turn them on, turn them off on when you're running your fans? Do I need to offer some free lunch vouchers to get some answers here? Come on. But, okay, the purpose of an automated system, utilizing the technology, is it takes that guesswork out, right? Because if you think about how a day progresses, we see it all the time. We start a bean harvest, it's 14% at 10 o'clock in the morning, by 2 o'clock it's 10%, right? That's because of how the air changes, right? There's how many hours in a day where that air is too dry, then we have a small window when the air is actually at a good condition to do what we want to do, and then that air gets too wet, then back to good, then back to dry. Up and down, up and down. You think about it, how many wasted hours of running our fans do we have by doing it that way? And what's the negative effect that we have from doing that? You think about that, especially in the case of soybeans that are way more adaptable to the introduction and reduction of moisture. We're negatively affecting the quality of that grain, right? Because hitting it with heat, hitting it with moisture, heat, moisture, those beans, they're going to be more susceptible to cracking, splitting, whatever else. That's going to lead to more dockage at the elevator, right? So the more we can limit what we need to do, the better to preserve the quality of that grain. But also too, I mean, that's just kind of a scenario, but when you look at that, when those fans are only running when they need to, again, one more positive impact back to the operation of looking at how that could reduce your energy costs. We typically will see about 25% minimum reduction in energy costs just from those fans only operating when they need to operate. So again, why did you build storage in the first place? Any one of these answers may be correct, but I need another 60,000 bushels worth of storage. I wanted to take more control of when I deliver my grain, sick of waiting in line. The neighbor built one that was bigger than mine. I got to show them up. All of them are valid, right? But it gets to thinking of, why did we do this storage in the first place? It wasn't just to be able to store it. We want to maximize our income on the operation, right? So to do that, you need to understand what your bin is all about. This stuff is pretty basic here, talking about the roof, the floor, vents, fans. But this is the part that I'm afraid not enough of us pay enough attention to. You look at really 3 different buckets that a bin falls into. And drying bin, that really takes about 1 CFM of airflow to be considered a drying bin. Have enough airflow to be able to either dry, hydrate, whatever you want to do to maximize that bin. If you're sitting at about a half CFM, that's what you call a dry aeration bin. Do some cooling, a little bit of drying. And an aeration bin, typically the type of bin that we would see coming out of the dryer. If we're unloading out of the dryer, put it in that aeration bin, cool it down a little bit before putting it in the main storage bin. So in my experience, what we typically find when we go out on farm to talk to someone about seeing if one of these systems is right for their operation, almost everybody thinks they have bin number 1, the drying bin, where in reality, most of them have somewhere between the dry aeration and just aeration bin. And there's a lot of reasons for that. Some good, some bad. Unfortunately, sometimes that comes down to, it's no different than anything else we're looking to buy. If we get to kind of going back and forth on price, pretty easy. One of the bigger things that can be done when building a bin is like, need to bring that price down. Maybe we don't need that 20 horse fan. We'll just get a 10. That'll do it, right? That could be a mistake. Sometimes the fan power is determined on what our electricity load is to the operation. Not everybody's on 3-phase. So we've got to worry about being on single phase, and do I need a 3-phase converter? Things like that. My ask is, if you're looking to build a bin for your operation, take the time to talk to your bin builder or who you're buying that bin from and have them identify with the fans that you're quoting me, what CFM do I have? So that way right from the get-go, what is that bin bin's capability? What is its potential to do for me? And then you can identify what is the purpose of that bin for your operation later on. Now, there's a lot of things we can do to adjust that, but that's one thing that I really like to highlight is like actually understand what does your bin have the capability of doing. So again, if you look at it, a lot of the university guidelines are going to say if you're going to be harvesting some corn at 20%, you need to have 1 CFM to be able to dry 20% corn just using air, okay? And that's going to be at a maximum height of 25 foot, so like a seven wide ring, you know, not all that high. We see a lot of bins out on the farm today that are much bigger than that, right? We're not getting maximum airflow because at about 25 foot with grain in there, that's kind of your sweet spot. That's your max efficiency point. As we get above 25 foot, we lose efficiency. We're still able to do some conditioning, but where you're going to be most efficient is at that 25-foot mark. Now, if you're looking at edging things out a little bit more and looking at some 25% moisture corn, you almost need to double that CFM and reduce your foot by 5 foot. So again, understand what we have for a tool. How useful is that tool to utilize my system?
You know what it is if you add heat?
Depends on the heater and the fan, right? So that's a great question. He asked if you couldn't hear it, what is it if you add heat? I don't know that exact number. I can probably find it out for you. But we do utilize that within our software, work with a number of growers that have heaters on their fans. It's a great opportunity if you've made that investment because you've just widened your heating potential, how much more outside of just utilizing what air conditions are. So I think from my experience and being on calls with some members of our dealer force and our sales team, I don't really think the CFM side of it changes. It's just the biggest thing that heater is going to do for you is just provide you more opportunities to be able to run the fans and get it done quicker. So, any other questions? Yes, sir.
Out of curiosity, where do the sensors go in the 50,000 bushel bin?
Great question. I'm just about there, so I'll show you here in a second. So that's a great question. So again, as we pull all this together, again, talk technology, this is what the system's designed to do. It's a fully automated grain conditioning system. You're going to be able to see the temperature, the moisture, and the inventory within that bin of that grain. Smart data platform connected cellularly. To your point, sir, this is what we look at. All the cables within our bins, the diameter of the bin determines how many cables we hang in it. They're going to be hanging from the roof, mounted with brackets across the ribs to spread out the weight load. And these green sensors here that are reading your temperature and moisture, they're going to be spaced every 2 foot on that cable. So at every 2 foot, you are getting a data point for what the temp and moisture is. Okay? So that gives us pretty consistent control. Put in perspective, talked with a gentleman outside earlier, 36-foot bin, we would look at putting 4 cables in that bin. 60-foot diameter bin, you're talking 8, right? So just looking at what do you need to do to cover this space. But how it all works together to be able to provide that information back for you is several things. You look at A being the control box. That's what you're going to do to set either a manual on or automatic, and that's telling that's going to be directly connected to your fans to tell them when to turn off and on. But that control box is getting information from B, the weather station. That's going to be telling us what the outside air temperature and humidity is to give it the knowledge to know whether it's time to run or not. Then that's going to also connect to the plenum sensor, or the air property sensor. That little device goes underneath the floor, mounted from outside the bin, but that's reading the temperature and humidity underneath the grain between the floor and the concrete. So that's telling the system, if I turn the fans on, based on the static pressure I have in this bin, how many degrees temperature rise is going to occur when I turn the fans on. Because I might have 65-degree air outside. The system knows I'm going to turn on. If I have 3 points or 3 inches of static pressure, now that becomes 68 degrees. Okay, it takes things like that into account. And then that also goes up to D, which is going to be your control box at the top of the bin. Again, that's going to be a system that's run off cellular connectivity, so you don't have to worry about Wi-Fi connectivity, Bluetooth, whatever. That's always going to be transmitting the information to your account via the cloud, and that's all coming from E, the cables there in the bin. And when you look at those cables in the bin, you're actually seeing them, again, mounted from the top. But before you start filling that bin, this is going to be the bottom. You're going to be about 18 to 24 inches off the floor of that bin, and we recommend tying them off with braided fishing line. That's about 100 to 120 pound test weight, and that's going to prevent the cables from swinging as you're filling the bin, keep them in check. And then because of that fishing line, when it's time to unload the bin, that sweep auger is going to go through, just cut through the line, and you don't have to worry about anything getting tangled or mangled within the bin, protecting your investment. So again, really what we look at it doing for the operation is pretty simple. Again, number one, safety, keeping you and everyone else safe on the farm, increasing your profitability. Again, soybean hydration is a realistic thing that can happen. We'll typically say you can bank on 1 to 3%. We say 1 to 3% because I don't know what the air conditions are going to be every year, right? Air might be dry, air might be wet, but as long as there's moisture outside, we have the ability to run the fans and put it back in the bin and put it to use for you. Back on the corn side for what our part of the operation, again, fans only running when they need to, limit the amount of over-dried corn that you have in the bottom portion of that bin, so you're getting more return for yourself. Peace of mind and knowing what's going on inside that bin at all times. Doesn't matter if you're sitting here at a soybean convention or if you're on vacation or you're running a tractor. You can pull up your phone, take a look, know what's going on inside the bin and the efficiency standpoint of it. So we keep it pretty simple on how to look at this whole process that we just talked about. We do at no cost an on-site assessment for anyone that's willing to let us come on farm and take a look at their system. We want it to be a safe storage assessment. We want it to be an educational experience. We want it to be a planning experience. We want to learn more about what is your marketing plan. How do you typically market your grain? How long do you store that grain? Things like that, so we can maximize what the capabilities of the system are to the best of our ability. But within that, we're going to look at your bins, identify the diameter, height, look at the fans, identify, do we have enough vents on that bin? That's another thing. Sometimes we don't always have enough vents. If it's an older bin, odds are we don't have enough vents on that to maximize the airflow within it. But within that, what we're going to do is we'll sit down and we'll then run an aeration model. And based upon the size of the bin, the size of your fans, we'll type in your zip code for where you're at, and we're going to utilize 10 years worth of NOAA weather data. And within that 10 years worth of NOAA weather data, we can show you conservatively every year for the last 10 years, if you would have had our system on that bin, how long would have it taken you to hit your target? And then it'll give you a 10-year average. And we try to do it that way because, as with all things in agriculture, there's always a year or two that stand out as either good or bad, right? You think about 2019 being really wet, okay, this year feels on the wet side. This is what I'm going to compare to 2012 being extremely dry. Probably don't need to run my fans a whole lot other than try to put some air in. So that's what we'll do. So we do all that to show you what that system is capable of doing as it sits today. Now, if we get through that and we identify, Mr. Farmer, Mrs. Farmer, you only have 0.35 CFM. I don't think you're going to be able to do what we want. We can rerun that model. We can actually look at, okay, is it as simple as adding horsepower to the fan? Do I need to add another fan? What do I need to do to increase the CFM back to that bin to be able to help you do what you want? And if it's something you are interested in doing, we can connect you with the right people. But again, helping you understand what is that bin capable of doing and how can you maximize it to its fullest potential. And again, last step, we talked about the EMC quite a bit earlier on. One thing all of our customers have the opportunity to utilize is our testing lab with Dr. John. Before harvest, before you're getting ready to harvest and start putting grain in that bin, call up your customer support rep, request a bucket for every bin that has a bin manager in it. As you're filling that bin, just take a sample and put it in that 7-gallon bucket. We provide all the postage and all that for it. It's zero cost to you. You send it into the lab. They go through the process of identifying what is the EMC of that grain that's going in that bin. And so that way you get it filled up, you put it to standard soybean, you get your results back. Your soybean variety is going to be listed in your account. You can set it to that, and it's going to naturally adjust to what the setting is. So again, making your bin a smart bin for you right there on the farm. So with that, that's really what I have for you today. I hope I didn't ramble on too much. Hopefully we provided some information on how to be safe, how to put some return back on the operation, how to maybe think about our bins a little bit differently than maybe we were before. I don't know. Maybe I hope something was of value to you. Any questions? Anyone? Appreciate the questions that were asked as we were going on. So, yes, sir.
A comment and a question.
Yes.
Comment. Many years ago, because I'm getting a little bit long in the tooth, I've been told, but when these ideas of having a monitoring system first came out, I put thought on a 10,000 bushel bin. And the biggest problem I had was mental. And that was the light thing would be kicking on when it was showering outside.
Yep.
And what in the hell is going on? And I was the old style, you turn it on, you turn it off, let it run all day, and I think, what is it doing? But it kind of did what you did, but it didn't, that's why I asked about the sensors. It didn't have near this kind of sophistication, which gets me to my next question. So assume you have a good bed, you have good fans, what approximately would it cost to instill one of your fancy bin managers on that 50,000 bushel bed? Roughly.
Okay, so good comment and good questions. To address your comment about just not letting it do its thing, you're not alone. Most of our brand new customers go through that same phase because there will be times where that bin is actually set to dry corn and it's raining outside and the fans are running and someone's thinking, oh, I bought a piece of junk. That thing ain't work. It's putting air. No, again, it's taking into account what the air conditions are outside, knowing what the temperature rise is going to be. You may be able to dry your grain while it's raining outside. So let the system do what it's going to do. To the cost, I don't have a great answer for you because it really depends on the size of the bin. So a 50,000 bushel bin, that could be a number of things. I would just say, think of it this way. Standard pricing is going to be anywhere between $15,000 and $20,000 fully installed. Again, that depends on this. You got to look at the diameter. Number one is diameter of bin, because again, 36-footer is going to take probably 4 cables. A 60-foot diameter is going to take 8. So that 60-footer, that's probably going to be a little bit higher. So I hate to throw out a number, but in respect, I'll give you that kind of a range. But then again, what is the height? How many rings high are we? All that comes into account. I will say, with that pricing, though, that includes, you're talking fully installed. The only added cost you're going to have is to have an electrician come out and connect the control box to the fans. Since I'm being recorded, I'll keep it at that. Well, keeping that, you got to have a certified electrician do it, and most of our dealers aren't going to be certified electricians. They're just, too many hats to wear. So, but pretty much any local electrician can take a look at the manual that we provide with the system and be able to get that done relatively quickly and easily for you. The other thing, you would have a subscription fee, and after pretty much 4 bins, your subscription fee is maxed out. So, you had a question, sir?
So does it really pay to put in a bin that is, 7 to 10,000, 24, 30-foot bins?
It takes longer, right? It's about like anything else in our industry. Volume pays faster, right? So I guess I can't. That's up to the person that has that bin, right? So how big of a component to your operation would that bin be? I mean, because like I said, The example I used was a 50,000 bushel bin, and I looked at a 21,000 bushel bin. I could make the argument that it pays in both situations. It's just based upon the commodity price and how many bushels we're running through it, how quickly can we have it pay for itself. In most cases, I can say, yeah, with what I just told that gentleman on the rough pricing, back in $12 bean days, I could make the argument that we could probably pay for that in its first year. If we're now looking at sub $10, it might take a year and a half. But to me, again, as a grower, as an agronomist, that's something that you can actually look at and show a direct return fairly easily and directly. We get thrown a lot of different products to the operation. They, oh, this will add 2 bushel, this will do this. This, to me, you're seeing that data 24/7. I can show you return on that. It's just based upon pricing, how long is it going to take you? So I guess, sorry, long answer. That's up to the grower. Like, you know, fewer bushels, the smaller the bushels, the smaller the bin is, fewer bushels it holds, probably the more bushels it's going to take to pay for itself. But over time, yes, it will pay for itself. So. But that being said, if that's the only storage you have as a grower, and you are depending on that grain to come out in good condition, well, I'm going to say that's pretty important in my operation. So it just depends. It's definitely not a one-size-fits-all. Yes, sir.
If you have like a 80,000 bushel bin, and you put it in at 10%, you use the system, you raise it up to 13%, so you're adding 3% volume into the bin. Is there a concern for lateral pressure on the bin splitting, that kind of thing, that is a lot of volume for
Yeah, great question. So again, when we look at soybean hydration, our system is designed to do it over a long period of time, right? Don't think of it as the garden spout into the auger as we're filling the truck. That's not what we're doing. We're not looking to flood the bin quickly with moisture, because that will happen. You will have expansion. Now, that being said, whether it's an 80,000 bushel bin, 50, 10, doesn't matter. If I have dry beans in there and I want to add moisture, okay, we know beans are going to swell a little bit. So I may want to reduce the number of bushels I put in the bin to account for that, because if I'm filling it all the way to the eave and leveling it out, because that's one thing we didn't talk about is like grain configuration within the bin. Let's say I leave the grain peaked inside that bin and I'm letting the air flow. At some point, you're going to have some beans running out the vents. You could have beans causing that roof to mushroom. So answer is, I'm not concerned about bin damage with our system, because we do it very conservatively over a long period of time. It's a gradual increase. But if you aren't paying attention, you can have some issues through that. So what I would say is, if I peak, for maximum airflow in a bin, you want to actually invert your bin, have an inverted cone. So what I would do, I would harvest and I'd take my peak out right away, invert it, and from doing that, you should be in a very safe space to be able to add 3% or whatever your goal may be. So, all right, well, with that, any other questions, feel free to reach out to me. I know Gracie has a sign-up sheet in the back of the room. If you'd like any additional information, please feel free to do that, but we'll be over at our booth space in the corner if you want to talk anymore. So thank you very much for allowing me the opportunity to speak with you today.